All right, everybody, welcome to the video here for lesson number 3 on using the long division algorithm. If after today's lesson you hate long division, it's totally okay. You can always use that tabular method we learned in lesson 2, but some questions actually wind up being easier using long division. So let's take a look at a couple of examples here. So we have 2x plus 1, 2x cubed, minus 13x squared, minus x, plus 3. So what we have to do here is figure out what multiplies by 2x to make 2x cubed. That's x squared. So I have 2x cubed, and I have a plus 1x squared. Now remember, this is all subtracted. The first term that we created should cancel. Negative 13 minus 1 is negative 14x squareds. Next term comes down. So now if we go through, I put in a negative 7x. That's going to make negative 14x squared and a negative 7x. Subtraction, these cancel, and we wind up getting plus 6x. So minus 3 comes down. Multiply by 3. These last two things should be the same. If they're not the same, that would make a remainder. We don't want remainders today. So there you go. Answer is x squared minus 7x plus 3. Next one, x plus 2. So I have 3x cubed plus 4x squared plus 7x plus 22. Not 12, 22. So first thing we got to make is 3x squared. That would be 3x squared up here. And that would give us plus 6x squared. Remember, this is subtracted. That gets those to cancel. 4 minus 6 is negative 2. 7x comes down. To make negative 2, I got to put in negative 2x. There you go. Got negative 4x. Again, remember, it's subtraction. These cancel. 7 minus negative 4, well, that's a plus, making it 11. 2 comes down, 11 and 22, those match. So when I subtract them, we get no remainder, which is what we want. So let's apply that process to the same exact problem, just written a little bit differently. So this question is asking us to take two different functions, f of x and h of x, and divide them without actually saying to divide them, right? That's what this tells us. So if I was to divide these, I'm going to put the 2x plus 3 outside the division symbol, and the 4x cubed plus 5x plus 21 inside. Now notice, there is a missing term here, right, where x squared normally would be, so we have to keep in mind that our like terms might not exactly match up. It's okay. So to make 4x cubed, we need 2x squared. That's going to give us 4x cubed and 6x squared. We are subtracting this. These cancel, but notice 5x and 6x squared are not like terms. So I'm just going to write them next to each other, the larger term first. Notice it's 6x squared because of the negative here. To make negative 6x squared, we use negative 3x. Subtract it, and these cancel. So we wind up getting a 14x, and the 21 comes down. To make 14, we're going to put plus 7. So we have 14x plus 21. This is subtraction, so we get nothing. So we could say f of x over h of x is equal to 2x squared minus 3x plus 7. It's a division problem without being a straight-up division problem. Number 3 was actually on a Regents exam a few years ago. So once it's determined the value of k, that would make it so that 3 minus x is a factor. So in class we talked about factors, right? Factors always have a remainder of 0. So I'm just going to do long division here. Now this is an example where I probably would not want the tabular method. It just makes everything a little bit more difficult. And I'm going to do everything exactly like I normally would do for a long division problem. I'm just going to have some thinking to do at the bottom. So I make 3x squared cubed. I would multiply that by x squared. I'll make 3x cubed minus 7x squared. Remember, it's subtraction. These cancel. 4 minus negative 7 becomes positive 3, and bring down the 5x. To make 3x squared, we're just going to put in an x minus 7x. Subtract, those cancel, and that gives us 12x plus k. Now, to make 12x, I'm going to put a 4 here. So that's going to make this 12x minus 28. Now, to make it so that these two things would cancel, I need k to be the same exact thing as negative 28. Because if you look at every other problem we've done, at the end, to make the remainder 0, every single time, I'm use a different color here. Doing this for Joey Castellonia because I know he's watching and he likes different colors. Every single time, the two numbers at the end were exactly the same. Every single time. So we want to make that happen here by making these two numbers exactly the same, which is why k is negative 28. Hopefully this video helps. Keep watching them and start preparing for a quiz at some point here as we keep getting more and more into the different methods here of division. Have a great night.